Good morning, everyone. Today we're going to talk about physical and chemical properties, physical and chemical changes, and then law of conservation of mass. So just remember, physical properties are ones that a substance displays without changing its composition. So its inside pieces stay the same. A chemical property, on the other hand, are ones that a substance displays through changing the composition. So I can only tell if a chemical property happened by changing the inside composition of that substance. So some common examples of physical properties are like odor, but flammability is a chemical property because in order to tell if something is flammable or not, you have to ignite it. All right, so let's do some problems. Physical and chemical properties. What would be the tendency of copper to turn green when exposed to air? So that one's going to be a chemical. Write it over here. Because once that happens, it's called oxidation. It's kind of like rust, and it can't be changed back until you've done another chemical reaction. Tendency of an automobile paint to dull over time. So this is also chemical. It is kind of a weird one though. It's because the paint is reacting with the sun over time. And so because of that, you're not going to be able to get it back to its original finish without repainting. C, the tendency of gas to evaporate. Evaporation is physical because all state changes, so going from liquid to gas, those are physical changes and physical properties. And then D, low mass of aluminum relative to other metals. That is also physical because I don't have to do anything to measure something's mass. Like chemically, I don't have to do anything. All right, let's see. We've got explosiveness. Anytime you see that word, it's going to be chemical. Bronze color. If it's just color and it's not color change, that's a physical property. The shiny appearance, that's also physical. The ability of dry ice to sublime, that is also physical because that's a physical change, like a state change. All right, so physical change of water. Just remember that when we change the state of matter, that's just a physical change. It is not a chemical change. Yes, it did form a gas, and before that was something that y'all used to identify a chemical change. But whenever it's changing states of matter, that's just a physical change. So our physical properties, we've got the boiling point of water. We know that at 100 degrees Celsius, water boils. Again, yes, it makes that steam, but that's just a state change. That's physical. So one thing to remember, state changes are always physical. So anytime we change from solid, liquid, gas, and I'm going to add and dissolving. Because when something dissolves, it changes from its solid state normally into a aqueous state because that's dissolved, like salt water. If we tried to get that salt back out of the water, we could evaporate all the water and then we would still have our solid salt crystals. As far as chemical changes go, those do change their inside composition, which is why copper turning green is a chemical property, because in order to get that back, we would have to then do another chemical change. So chemical properties, another one would be rusting. In order for you to get rust back to its original iron, you've got to do another chemical change. So matter undergoes a chemical change when it undergoes a reaction. Substances before the arrow are called reactants, and after the arrow, they're called products. And from here on out, I'm going to refer to them as that. This arrow means a chemical change happened in a chemical reaction. So physical changes are a different form of the same substance. So their size may change, their state of matter may change, things like that. A chemical change, on the other hand, results in a completely new substance. Like with rust, we started with iron, and now it is iron oxide. So that's a completely new substance. Now we're going to talk about some physical changes and the words we use with different states of matter. So vaporization is the first one. Vaporization is when we go from liquid to gas. So when you push down on the lighter to release the gas, that is just going from liquid to gas in a butane lighter, so it is still a physical change. Once we ignite the lighter, then it becomes a chemical change because now it is no longer butane. It is now water and carbon dioxide particles. Some ways to separate mixtures with physical means. Distillation is one. Distillation is used to separate two liquids that have different boiling points. Okay, so what happens is the one with a lower boiling point will evaporate first. It comes up the round bottom flask, and then it comes down, it cools, and it collects down in this bottom one after it's cooled. Okay, this is something that if you get to organic chemistry, they do a lot of distillation. It's very important. Even during the time of COVID where at Eastfield we're all online, they're still doing like 4 labs for organic because it's very important that you're doing labs. It's not just simulations. Okay. Students that would need organic are anybody pre-med, pre-vet, pre-dental, pre-pharmacy, all of those. And then obviously if you're majoring in chemistry, I did have to take it with my physics degree. And then, which is kind of weird because it's not really physical, but that's okay. And if you want to be a chemical engineer. So all engineers need chemistry like across the board, but then chemical engineers obviously will need more chemistry. Filtration is another way, and we normally do some filtering in this class, but because we're in this online environment and people will stay in the online environment with VLA, that's gonna probably not happen this year. We'll do some simulations, but basically we have a liquid mixture. It normally looks like a liquid mixture because it's got those dissolved particles. Depending on how small your filter paper is, it will trap the solid particles. And then you've got the liquid component in the beaker and your solid components on your filter. And then normally you dry it either by just waiting for it to dry, or we can heat it in the oven, or we can use vacuum filtration, which will suck all the water down, or the liquid, and then it'll dry faster. All right, so let's look at some physical and chemical changes. So rusting, that is chemical. I cannot get that back unless I do a reaction. Evaporation, that is a physical change because it's changing states from liquid to gas. Burning, once you've burned coal, you're done. You can't get that coal back, so that's chemical. Most of the time when you see burning, it's chemical. And then D, fading of carpet upon repeated exposure to sunlight. Again, that one's a weird one. I'm not going to ask any like that, but they're going to say it's chemical because it's reacting with the sun. You're not going to be able to get it back to its original finish, kind of like the car. All right. Copper metal forming blue solution when dropped into colorless nitric acid. So that one is a chemical change because the acid, just remember, anytime you see the word acid, it's probably going to react. Okay, because acid does a lot of reacting. A train flattening a penny. So it's still a penny. It's just a flat penny. Ice melting, that is also physical. And to match igniting, anytime you see fire, it's pretty much going to be chemical because once you've lit it, you're done. No more of your original substance. All right, now to law of conservation of mass. So, something to keep in mind, I know y'all have talked about this before in the past. There is no new matter. The law of conservation of mass says matter is neither created or destroyed. It just changes form. Okay? It's very important. Matter is not created or destroyed, as is mass. Mass needs to be the same when you start, the same when you end. Okay, so here we've got an example. We've got a reaction with products and reactants. We've got butane and oxygen react to form these products, carbon dioxide and water. Notice the reactants add up to equal the products. So The arrow in this situation is like an equal sign where we're doing this math. Okay, so you don't even have to know what's what. You just have to know that what's on what side. So a chemist forms, that means potassium iodide. And again, I know you don't know what that is. And then the other two are formed by combining potassium and iodide. Okay, and hopefully you remember from 8th grade, this is clearly not balanced. So if we wanted to do that, there, now we're balanced. Okay, tells us we have 3.9 grams, and I have 12.7 grams. On the other side, I have 16.6 grams, and it wants to know, show that these results are consistent. So the way I need to do that is the reactants need to equal the products. Okay, so the reactants are 16.6 grams. So yes, it is consistent. Okay, this next one. We've got 12 grams of natural gas that combines with oxygen. So I'm going to write gas plus oxygen yields carbon dioxide and water. It says the chemical change produces carbon dioxide, and it wants to know how many grams of water. So I've got 12 grams, 48 grams. Carbon dioxide is 33 grams, and I need to know what water is. Okay, so this side is 60. Okay, which makes it 27 grams of water because it's got to add up to the other side, which is 60 grams. Okay, that's it for the day. Y'all have a great day.